Hello everyone, this is Group 10. Social media has boosted the music industry. There are more and more artists creating incredible music around the world, so we want to forecast and optimize the best songs on Spotify for every year. This is the table of content. First is the motivation. Second, we're going to talk about our data set. And third, forecasting. Last but not least, optimization. Motivation. We want to analyze and forecast while optimizing the results of next year's best songs to help out the artist. And how? Is we find out that the best songs for every year, ranging from different genres, BPM, or even from different singers. We collected our data from Kango, and I'm gonna show you our rough data from Kango. Here, as you can see, that there are many categories included in this table. So first is the title of the song, second is the artist, third is the genre, and third year, and other different categories. As you can see that there are 6 songs of 2023 included in this table. We found out that in a year, there can be many songs included, not only in 2023, also like 2022 and 2020, and 2020 and 2019, and so on. So, the first step, we needed to sort the data set based on the year, organizing the songs chronologically. And step 2, we compute the average values of key features such as BPM, danceability for the best songs within each year. And step 3, we have to pre-process the data. We found out that the rough data is too big and will cause the code lab to run slow, so we derived the distinct feature associated with the best songs for each year. This is the pre-processed data. There are the average of every year's best songs. Number 3, forecast. We use lasso method to select the essential factor while eliminating those exhibit a similar impact on popularity, but are comparatively weaker when compared to essential factor. Based on the lasso result, it is observed that BPM over here and liveliness have negative coefficient, suggesting a negative association with popularity. However, the coefficient for liveliness, negative 0.0128, is smaller in magnitude compared to BPM 0.142004, indicating that BPM has slightly stronger impact on popularity. So, we decided to drop the feature liveliness since it's comparatively weaker in its impact. Then we employed multiple regression analysis to predict popularity with the following independent variables: energy, danceability, BPM, and so on. Basically, we include all the number categories. And this is the result. As you can see, the coefficient of different categories are listed over here. These results show how well the regression model's prediction align with the observed popularity values. The last part, optimization. Step 1. We aim to identify the optimal attribute arrangement for a song by maximizing popularity. This will aid pop songs writer in initiating their compositions. And this is the initial value that we assign for optimization. But since the objective function is not linear, so using 0 as initial value may not lead to optimal solution. So we set BPM as 50 to 160, energy as 0 to 100. This is the code of optimization. The purpose of this code is to find the optimal values of the 8 attributes, G0, G1 to G7, that minimize the objective function. which in turn represents the predicted probability. The constraints ensure that the optimized values fall within specific range for each attribute. The output provides the random initial values, the optimized popularity values, and the final arrangement of attribute values that minimize the objective function. Step 2. We utilize the forecast result to optimize the popularity. And this is the result. And in the next page, we're going to show you a better looking table of the results. Yes. So the result of the optimization is energy is 100, then stability 100, and so on. So using the initial value that we gave, we had this result, and after having this result, this is the final result of popularity that we get, 174.63. So this is our project. Thank you for listening.